We now want to find the zeros of this function and then write it as a product of linear factors. For the most part, we're going to follow the exact same process we did on the last problem. We're going to start out by finding our possible rational zeros. Once again, we need to take the factors of our constant, in this case the factors of -6, divided by the factors of our leading coefficient, which is 3. Then list all your possible rational zeros. When you pair those all up, the 1 with each one of these down here, the 2 with each one of these down here, the 3 with each one of those, and so on, you would get these. You now want to go ahead and find m. Remember, m is your largest leading coefficient or constant, which in this case is the 24, over your leading coefficient plus 1. So it really ends up being 8 plus 1, or 9. So your x minimum on your window will be a -9. Your x maximum would be a +9. So then we want to go ahead and graph our original function to see which ones of these possible rational zeros actually end up working for us. So we're going to go ahead and do our window. And this should be from a -9 to a +9. Then you'd want to go ahead and graph that. And it does not end up being a really good graph. You'll notice we didn't need to go out nearly as far. Here's your axis right here in the middle. So we only had to go to like -2 here and maybe like a 3 or a 4 over there. So let's adjust our window. And then we'll regraph. Now we want to take a look at our possible rational zeros up above here in orange. And then we want to look at our graph. And we want to say, based on our graph and our possible rational zeros, what appears to be working? Well, it appears that -1 works, of multiplicity 2, because it bounces off. It also appears that 1/3 works, because here's 1, it's not halfway there, and 1/3 is a possibility. It also looks like 2 works, and it also looks like 3 works. So we need to go ahead and try these numbers using synthetic division into our original to see if they actually do work. So we're going to start off by using -1 into our original, and we're going to go ahead and do synthetic division. Drop the 3, multiply, add, multiply, add, multiply, add, multiply, add, multiply, and add. And you'll notice that yes, -1 does work. But since it says -1 multiplicity 2 because it bounced off, we should go ahead and try -1 again. But we're only going to work within our quotient because we don't want to go back to the original. We only want to work with the quotient. So we're going to only work with the quotient and try -1 again. And -1 works again, which we anticipated. Now that we've tried -1, we have our options of a third, 2, or 3 to try again. Well, I don't really want to work with a fraction unless I need to, so I'm going to try 2, and then once again, I'm only going to try that into my quotient. And then we'll drop the 3, multiply, and continue. And you'll see that 2 also works. Now, when you look at what you have left here, we only have 3 terms left. Since we only have 3 terms left, we know we're dealing with a quadratic. So we know it's going to be a 3, and then a -10x, and then a 3x squared. All we have to do is go ahead and solve that. If you were not able to see how to factor this, you could also go ahead and use your quadratic formula. When we factor it, we do end up getting a 1/3, and we do end up getting our 3. So all of our zeros are what we had suspected from looking at your graph. -1 multiplicity 2, a 1/3, a 2, and a 3. So that means for our factors, we get an x minus 2, an x plus 1 showing up twice, a 3x minus 1, and an x minus 3. And you might be wondering, where does that come from? Well, here, this is x equaling a 1/3. Multiply both sides by 3. Subtract 1, add 1. Try again, subtract 1. And so there you can see where this comes from, just by setting it equal to 0 after we go ahead and get rid of the fractions. So now we want to repeat that process for this last problem. Once again, find your possible rational zeros. So it's factors of your constant, factors of the 20, over the factors of your leading coefficient, factors of the 3. Then you want to go ahead and list all your different possibilities. Taking all your red ones over each one of the pink ones, list out all those different possibilities. You then want to go ahead and find m. Remember, m is your largest leading or coefficient or constant, which is the 20, over your leading plus 1. So when you do that, you end up getting m to be 23/3. So your x minimum on your calculator will be -23/3. X max will be +23/3. So now we want to go ahead and graph that, making sure you set up your window to a -23/3 and a +23/3. Your y's, just so you're just below and just above. You then want to graph that. You'll notice we don't have a lot showing up on our graph. So I'm going to just kind of zoom in more on where it looks like we're crossing to get a better idea of what we might be looking at. So I'm going to go from 0 all the way over to 2. When you just graph it between 0 and 2, you get this. Well, when you look at your possible rational zeros and what you have here as a possibility, it looks like your only possible one that is reasonable is 4/3. So we're going to try 4/3 because that's what we suspected from looking at our graph. Put it into our original, and then we'll do the synthetic. And indeed, it does work. Now, once again, we only ended up with 3 terms. That means what we have is quadratic. So it's going to be a 3x squared plus a 3x plus a 15. To make it easier to work with, let's just go ahead and divide everything by 3. Divide both sides by 3, and we get this. So now all we have to do is solve that. It's not going to factor nicely, so we'll just use our quadratic formula. -1 plus or minus, and what's inside your root reduces down to -19. We don't want to have a negative in our root, so remember that negative comes out as an I. So we get -1 plus or minus an I, root 19, all over 2. So our zeros that we came up with are the 4/3, and then our plus or minus an I, root 19, all over 2. Now, why weren't all of our possible rationals, or all of our zeros, listed in the possible rational zeros? Well, the 4/3 was. But this right here, that's not a rational number. It's a complex number because it has I, and irrational because it has a root. So it's not rational.